What up, dudes? Here's what we got, and it's a little bit kind of complicated, but here's the problem. This one, it doesn't give you an option A, B, C, or D. This is called a grid-in, and it's on the SAT. But I'll be honest with you, the Smarter Balance test, the Common Core, that's the Common Core one. The ACT, all of this kind of stuff, I bet you is going to be moving into this direction. So some of these problems, you're not going to have multiple choice. You're just going to have the little bubbles to fill in A, B, C, and you actually give a number. My hint to you is don't think that your calculator is your salvation. One of the biggest mistakes you can make is immediately going down to the calculator and saying, oh, okay, I'm going to plug in every single thing. And sometimes they do it to mess you up. Now, with these tests going in the direction of being online and being the computer-based, you'll always have a calculator available to you. But think about this. Back when I was going to school, we walked uphill both ways in the rain. And we did school without this Google thing that you have. I don't know why I'm talking like Bill Cosby, but I'm just saying. It's like back in my days, you had to bring your calculator. Now what happens if your calculator ran out of batteries, or if your calculator broke, or if you forgot your calculator? The test makers in those days would make the problems so that you can solve these problems without the use of a calculator. And I don't think that they lost that sight, that they lost that mentality. In fact, if you find yourself having to use a calculator the whole time, then you're probably doing the problem wrong. Here's this problem. I have the numbers 1 through 44. It's not 1 minus 44, it's 1 to 44, inclusive, so that means it's including 1 and 44. And I add them all up. Sum. That's what it's called, the word sum. And I sum up all the numbers from 7 to 50, and I get some giant number here and some giant number here. I'm going to call this giant number 1 and this giant number 2. And then I take giant number 2 and I subtract it from giant number 1. My question is, what is my answer? That's the question. All right. What you would be tempted to do, and I think this is a terrible idea, is to immediately jump into your calculator and go, okay, well, what's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, blah, 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 blah. And actually, plug it all in and figure out what giant number 1 is. And then, okay, now I'm going to do 7. So I'm going to start at 7. 7 plus 8 plus 9 plus 10 plus 11 plus 12. Go all the way up to 50. You get giant number 2, and then you subtract the 2, and then you'll be happy. Yeah, not the right approach. You could do that. I guarantee you that would be about pressing 252 keys in the correct order. You're going to make a mistake somewhere. To solve this problem, there's a few ways to do it, and I think that one of my favorite ways would probably be inspired by Carl Gauss. If you don't know who that is, look him up. He's a great mathematician. But I think that maybe the best way to show you how to do this is to choose different numbers. I'm just going to choose different numbers so that we can see the approach that I'm going to go for here. Let's say, all right, fine. I'm going to go from the number 1 to the number 4. So I have 1, 2, 3, 4. I want to add up all of these numbers, 1, 2, 3, 4. And I'm going to subtract that. I'm going to start a little bit higher, so I'm going to start at 2 and go up to 6. 3, 4, 5, 6. I made these numbers smaller, just so I could see the pattern here. Now if I take this number, this plus this plus this plus that, and I subtract it from this plus that, that plus that plus that, or maybe I should put a minus sign in the beginning, minus, 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 because really I'm subtracting each of these things. Essentially what I see here is that this 2 will cancel out with that 2. This 3 will cancel out with that 3, 4 and 4. See what I mean? So now the question is, well, what's left over? Left over is positive 5, positive 6, and negative 1. What's 5 plus 6 minus 1? Okay, that's just 10. I'll be honest with you, to me that seems like a lot easier to do. You can scale this up and get the same idea. If I have the numbers 1 through 44, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 44. I'm going to subtract all of them. Okay, the dot means, so on and so forth. I want to subtract that from positive 7, 8, 44, 45, 46, 47, 48, 49, 50. Add all of these things. There we go. What cancels out? I would say that everything between 7 and 44 kills each other. So really, at that point, you can take your calculator and just say, all right, well, what's 45 plus 46 plus 47 plus 48 plus 49 plus 50? You can plug those numbers in. And you subtract 1, minus 2, minus 3, minus 4, minus 5, minus 6. Because that's what's left over. And you end up getting 264. Now, there are more creative ways. There's probably a faster way, an easier way, or whatever. I think that this is, I don't know if there's an easier way per se, but I think that this is maybe the balance. Because I can actually think of a much cleverer way to solve this. And I'll be honest with you, I'm not going to share that with you right now because I want you to kind of learn this technique. I would say this is the middle of the road. This is not the quickest way. It's not the most clever way. You still have to add up 45 plus 46 plus 47 plus 48 plus 49 plus 50 and then subtract 1, 2, 3, 4, 5, 6. It's much more reasonable than adding up all 1 through 44 and adding up all 1, 7 through 50 and then subtracting those two numbers and whatever. But I would say that this is maybe the middle of the road because it's not that hard to understand. It's not that hard to do. That's my answer.